Okay. So you're talking about data visualization, okay? And what is data visualization? See, I don't have to express or tell you about that. The visualization is very powerful, right? We all know that. They say, right? If you show something, people remember 80% of the stuff compared to just 20% when you speak, correct? So obviously um, there is more retention capability when you show the graph. And that's why in any analysis, it is better to create a graph and plot, isn't it? Because graph and plot will give you um, will so it's like, see, if you look at same this graph, right? Tell me what you understand. Just take a second or minute to look at this, okay, and tell me what you understand, and then I'll talk about it. So it has a heading, subheading, and a map, right? So what do you think this is trying to say, convey?
So it seems in 2014, the whole America talked about on Twitter. There are some spikes specific to some of the topics.
Correct, correct. So you have those hashtag, right? So so this is taking it is this plot is taking all the hashtag that came out of US in the 14, and by every day, right? If you see, it's a daily thing, okay? And daily thing, it's talking about um, a different aspect that people are talking about. And of course, as you said, spikes are those special event, okay? And so many tweets were given in those um, on those topics. Now, if you have to explain the same logic in text, okay, one, it's going to take a lot of effort and lot of pages. Now this fits in 1/3 of a page, correct? But you have to talk about that, you have to talk about each topic first, then talk about days on which it was tweeted, right? So it will definitely take you at least a page to write. And second thing is, everybody has their own way of writing. It is possible that when I write something, it you don't understand the same way I intend to write. This is a big challenge when you write something. When you write a story generally, right? If it is one line, two line bullet points, it is still better. But when you write in paragraphs, it can also, not everybody has great writing skills, right? If we have good writing skill, probably people will understand. But let's say if I'm not good at writing, I might make mistake, or I might end up doing something which might give different meaning to it, correct? So we don't want that. So when you draw something, you don't even have to explain. People, while looking at it, they know what you are trying to convey. And that is the importance of charts and plots, right? And whether it is data science, data analytics, okay, charts and plots are very useful. And this is the last um, uh, thing that you do after you analyze the data. This is the last thing that you do, because you have to present it to the different team, right? And you don't have to explain, okay? People can clearly see. Now if you see Ferguson grand jury, okay, that was the highest uh, tweets that were tweeted in the whole year, right? Because obviously the spike is highest. So when you create the spike should also be in some ratio format, okay? Even though a spike here in grand jury is showing biggest, okay, in reality, let's say Ebola in US was the biggest, then this is graph is wrong. This graph is not showing it's not conveying correct message. So the way you have laid down from Jan to December, you cannot say Jan, May, then April, then Feb. So what happens then? It will be very difficult for people to see. The graph will be correct in that case also, right? But it will be difficult for people to understand, okay? Because now you see that when you look at it, you know that Sony Cuba was the last topic of the year that was trending. Okay, State of the Union was the first topic that was trending in the year, right? But if you put, somewhere in any order, if you put every month data, then it becomes a lot of, as a reader, you have to put a lot of effort to understand what's going on, right? So the way you choose the scale, the way you choose the graph, what graph should you plot, right? Probably for this graph looks better. If you had line graph, bar graph, would have probably may not have made more impact, right? So the graph that you choose, okay, all those things makes impression on the viewers. Okay, your intention, see, it's not about using complex tool, it's not about using complex graph. Whatever is easy for your audience to understand, that is it. Okay, it should be engaging, it should look good to the reader's eyes, so that sometimes you select those colors also might, people would focus on the colors, not on your presentation, and you don't want to do that. You want people to look at your graph and plot, not at your colors, right? So everything that you select, everything that you do actually creates an impact on the user. Definitely this actually gives a lot more visibility or information than any one of these. So what do we do? Okay, I'm not going to talk about it, we all know. Okay, the purpose of graph is to show the data, induce the viewer to think about the substance rather than the methodology. Graph, that's what I said, they should not look at what method you use, what color you use. Focus should be the substance. What is that you're trying to convey? Avoid distorting the data. Right now, again, as I said, right, if I had put Ebola in US as a bigger bar, I could have written on the graph that spike is not as per scale. I can write it. Spike is not as per. This is what happens when you look at the real estate people, right? If they have to talk about, okay, one second. Yeah, sorry, some important calls I had to take. Okay, so I was talking about, okay, so let's say in the real estate thing, right? They will show some land very far off, right? And they will put in such a way that it will look very closer to the, let's say your high-tech city or some kind of, important location. And they'll mention, the graph is not as per scale. They don't want to show that area too far from city limit or from some kind of important location, so they will put it closer. Okay, and they will say that it's not so when you look at the graph, it will look as if, oh, that town, the village is so near to the, say, food park, or so near to IT park, right? So that's called distorting of data, right? Do not distort the data. Intention is not to distort the data. Do not do that. Okay, and of course, now in the last graph we saw, we have so many tweets. I'm sure, I think the number was given, right? 184 million tweets were fired, right? So even though we have 184 million tweets to plot, we are able to do that within, one third of a page. So
Swapnil, are you sharing that image or content and what? I see the
content.
Okay.
Is it not moving?
Now it's moving. Yeah.
Okay. So yeah, so that's the purpose. Okay, show large data in a coherent manner. It should be easy to your eyes. It should not use color or things like that, which is not on eyes. It should reveal data at several levels of detail, as much levels as possible, without making understanding difficult, without making understanding complex. Okay, that's another key. Without making understanding complex. Sometimes you put a lot of information and people is not able to get what you're trying to say. So we have to reveal as much information, but to an extent that it's easy for people to visualize and understand. Okay, so yeah, that's the purpose, I'm sure, and you can understand all these things. I'm not going to talk about all this. So these are different types of graph. Okay, we'll do it later. Okay, I'm going to talk about what is time series and ranking when we talk about data. Okay, so let's skip to this. And okay, again, why it is important, you all know, so I'm not have to focus on it. But from where does it start? Okay, okay, what graph should you plot? So it always starts from a business objective. Okay. Now, if you see here, there's a CMO of a company, Chief Marketing Officer, and she wants to understand, okay, what is the budget? See, every company, right? And for that matter, let's say your HR also, right? If they have to decide the salary hikes, okay, what should be minimum, what should be maximum, how much salary hike on average should we give? So there's a lot of factors that decide. Okay, so they will talk to different the research, reputed research organization. They'll talk about, now let's say if you are thinking, okay, to compete against company ABC. Okay, see, now every company, there are so many IT companies, right? And not all wants to compete with all. They have identified the companies with which they want to compete. So if your target company is ABC, let's say, you wanted to compare against ABC. Now, if ABC is giving 15%, then you cannot give 6%, 7%. Okay, there may be companies that they might give 15% average hike, but that's not your competitor. Your competitor is ABC. So you want to be in close rank, you want to be best among ABC or within some range within ABC. You don't want, your talent to go to ABC. That's what the main problem is. Okay, so they look at what ABC is doing. So it's very natural for every company to look at what industry is doing, what your competitors are doing, and then you will also do in similar range. So CMO, okay, wants to understand the how much company industry is spending on marketing. Okay, because they also have to allocate some budget for marketing for that year. So what they have done, they have looked at 10 years budgeting expense of companies, and this will be in your similar in your domain areas. Okay, so they had, like, companies had 1.1% in 2009, then 9.2. Okay, it's increasing again, going up, right? It depends upon the industry. If industry is going down, okay, you don't want to spend more money on marketing, right? But if industry is going up, there's more demand, you want to put more money on marketing so that you get more customer. So they look at the graph and they see that about 8.7% is the marketing spend. So you also have to put something in that range, right? So the graph should also help you to understand or solve your business objective, right? So this is one, okay, that where you look at the marketing spend. Okay. Now this is your graph. Okay, that was company, mark industry. This is what you are doing. Now, if you see, okay, and this doesn't make, okay, let me put it together, but doesn't, okay, that here graph is mostly about 4 to 6% and somewhere 9%, and here it is about 9, 10, 12%. That means this company is always spending more than the industry average, right? So if industry average is 5, they spend 9. Industry average is 10, they spend 12. So they're already spending more than industry average, and that's what they want to be at, right? Coke and Pepsi, they probably want to spend more on marketing than any company. It's their choice. Okay, but if you see the trend will be more or less same. Okay, that means if industry is not spending money on marketing, even this company will spend less money on marketing. So trend will be very similar. Budget could be different. So here, okay, so they know that, okay, they are about 2-3% higher than the industry average. So if they know the industry average, they can decide at what percentage they will promote their product. So you have to look at various data. You have to look at various data. You have to look at various parameter to make your decision. Okay, so I have an example for you. Okay, okay, same thing. I have it in a PPT format. Okay, so you all can see the date, some numbers right on the screen, long distance telephone numbers.
Yes.
Okay, so let me ask you a question. There's a marketing manager of a telephone provider. Okay, so let's say you talk about anything, it could be Vodafone or Airtel. Okay, now they have taken sample data. Okay, not all data, sample data of 200 people. So they have 200 records. Okay, there are 200 numbers. They have taken sample data of 200 customers. Okay, and what they say, I mean, they want to see how much money they are spending on international calls. So they have lakhs of customer, of course, subscriber. They are focusing only on people who are spending on international calls. Okay, and they have taken 200 customers, and the values are in dollars, so you can probably extrapolate it to 10 times or something like that. Okay, so if you see 42, read it like 420 rupees, something like that. Okay, so it's in dollar. So and this marketing manager wants to look at the data set and come up with some kind of analysis, some kind of recommendation to the company. Okay, now you tell me, when you look at these numbers, right, what does this tell you? How do you interpret these numbers? Can you make any sense out of it?
No,
No.
No, right?
I can't.
No, not true. Probably, say if you had 4 or 5 numbers, probably yes. We have 200 numbers. It's all just numbers, right? You can't make any sense out of it. True. Okay. So what you do, I mean, at max, what you can say is, okay, minimum is 0. I can see a few zeros here. Maximum is like 118, 120, maybe somewhere. Okay. 100 plus, there are a few 100 plus, right? That's all you can say. So when you read the data, okay, the first step is to, when you're doing a business analytics, right? First step is always to find the objective. What is your objective, right? In this case, objective of this person, okay, is to look at the data and come up with some kind of recommendation for customers using long distance calling, right? Now, what recommendations we don't know, right? Maybe he's trying to figure out, he or she's trying to figure out, can we find some pattern, can we find some information which I can generalize or I can recommend to the business, right? That's where your thinking has started. Okay, that is your, I just said, your business requirement, right? So business requirement is not like, okay, I have got hammer, so let me start hitting everywhere. Okay, you have a nail and you want to hit nail, then you get hammer. All right, so you have a business problem, and based on business problem, you are looking at the data. What kind of data can I collect? Okay, so here, okay, you have got 200 data. That's step 2. Step 2 is get the relevant data. Step 3, we call it as EDA. Okay, EDA stands for exploratory data analysis. Okay, step 3 is where you plot different graphs. Okay, and then from the graph you are trying to understand what data is trying to say. As I said, 200 data with naked eye is not possible. So can we put it in some format, some presentation, some plot, some graph, which will give us some message or something to look at? Okay, so what we have done here is we have created a frequency table. Okay, so that's your step number 3. Create EDA plots. Okay, this is small data set, so one plot is enough. Sometimes you might have to create multiple plots. So what we have done, okay, frequency distribution, we have created these buckets. So when you look at maximum data, okay, if you see here, there's given somewhere. Okay, maximum is 119.63 maximum value, and minimum is of course 0. So what this fellow has done, he has created these buckets: 0 to 15, 15 to 30, 30 to 45, 45 to 60, so on, up to 120. Why only 120? Because maximum number is 119.63. So 120 is what you have to do, right? Now, so between 0 to 120, you have to create buckets. Okay, between 120, 0 to 120, okay, you should have around 10 groups, around 10. It can be 8, 9, it can be 11, 12. Okay, generally 10 is what we look at, because less than 8 or 7 will be too few classes to look at. Okay, it's like too less data. If you do more than 14, 15, it will be too many classes to look at. Okay, so what histogram says is try to create around 10. Okay, you will not get exact 10, so maybe create 8, 9, 11, 12 such classes. So here, you have options to create from 0 to 10, 10 to 20, 20 to 30, up to 120. That means you'll end up creating around 12, 13 groups, which is on the higher side. Okay, but also is fine. You can create 0 to 10 also, not not a problem. Okay, around 12, 13 is good. You could have done 0 to 20. In 0 to 20, you would have got only 6 or 7, right? Two less. So what this fellow has done is has created 0 to 15. So 15 is the range. 0 to 15, 15 to 30. See, once you decide the range, all the classes should have same range. I cannot say 0 to 20, 20 to 100, 100 to 120. Okay. Each class should have same range. Then only it makes sense. You cannot say 0 to 20, 20 to 100, 100 to 120, right? No. If you say gap of 10, everything should be gap of 10 only, or 20 to 20 only. Right? Here 15, so it is 15. Yes.
So, like we
I lost your voice.
hello, I'm audible.
Yes, now you're audible.
Yeah. So, like we can take the difference of 10 to, no, like 0 to
Correct,
10,
correct. So that's
then
what I'm
10 to
saying. You could do 10 also, but 10 would be little more. That's what I'm saying. You end up getting 13,
okay.
14 classes. And if you do 20, you'll get around 6 or 7 classes. So you can do 10 also, you can do 20 also, but 15 is probably better here. Okay. You can do 10 also, not a problem. Okay, you can do 10. There is no hard and fast rule that you have to do 15 only. Try to keep it as close to 10 classes, 10 groups. That's what I'm trying to
Yeah.
say. Yes, you
Mm.
can do 0 to 20, but 0 to 20 if you do, you'll end up with less number of classes. 0 to 10, you end up getting more classes. But that's fine. Okay, there's no rule that in statistics, in data science, okay, all these are recommendation. Okay, if your experience will always out shine, or will always be given priority over statistics. Okay, we have some standard values. Okay, create 10 classes, but your experience is no, you have to create 20 classes. That is right. Okay, what your experience says is right. Okay, but statistics is good for those who do not have experience. If you do not have experience, then go by the numbers, right? But if you get more and more, you'll do it one time, two times, you'll do it. Third time, you will only say no, 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 15 does not look good, let's me do with 10, right? And then with more experience, you say no, 10 is good, right? So what I'm saying is there's no hard and fast rule. There's no such rule that it has to be like this. Statistics only recommends. Okay, it does not enforces. Yes, you're right, you can do for 10 also, but here let's say this fellow has done for 15. And frequency is number of values that appear within that duration. Okay, so 0 to 15, there are 71 customers who have billed between 0 and 15. 71 out of 100. So so 1/3 is in first range itself. Then you have 15 to 30. So once you create this frequency table, then you draw histogram. This is called histogram. So histogram is a bar graph. Okay, it is like a bar graph only. It is bar graph which has frequency or count on y-axis. This is your y-axis, isn't it? So frequency will be on y-axis.
Y-axis.
Okay, and values on your x-axis. That's the that's how histogram work. Okay, so you create this histogram. And now, can you see something out of it? Can you make any sense out of histogram? Definitely, this is easier to analyze than those numbers, isn't it? You can maybe make some analysis. So third step, as I said, is to create these plots. You call EDA. And then, okay, you're observing what is there, observing. So this fellow has observed this. So when he looked at the histogram, he is able to, differentiate the data into three groups. 0 to 30 constitutes of more than 50%, and their bill size is less, okay, less than $30. So I mean, $0 to $30. How many customers are there? 108, about 50%. Okay, and then there are very few between 30 to 75, and then more than 35, more than 90. Okay, they are 90%. More than 75, they are probably 40%. 50% is here, 40% is there, 30%. Middle, okay, middle, if you see 30 to 75 or 90, it's a big range, right? Okay, only 10-15% people are there.
Yeah.
Okay, now this is observation. Now tell me, what kind of recommendation will you make? Now it is easy to make a recommendation, right? Tell me, can you make any recommendation for this? Okay, so let me help you with this. So the first thing you have to remember is domain knowledge is important. Okay, now this graph can mean different thing for different business. Let's say instead of telephone provider, let's assume this is your retail business. You're running a retail business and you're analyzing your retail store, this thing. So in retail store, you want your customer to buy more. Average ticket price, you want people to buy more, right? If they're buying like $15, $30, probably it is less for you as a business. You want them to buy $50, $100. So you have 30% people with whom they are your good buyers, right? This 50% are probably not your good buyers. How can you make this 50% people buy more? You want to move this middle people into right side group and the left side people into at least middle. Okay, you want them to increase their spending.
So I just pull out the data of that 50% people and communicate them with some offers and try to convert in that
Yes,
30%.
yes, okay, yes, that's right. Okay, because you have to, that's how your business will grow, right? You have to make them buy this. This is true when you're running a retail store, but if you're running a telephone service providing business, exactly opposite is your intention. Okay,
Yeah.
those people who are spending more with you, they are easy target for your competitors. If competitors say that we are offering some discount on international calling, these people will leave you and go.
Mm.
Okay, that's why, see, when you log in, okay, for recharge, any service provider you take, Airtel, Vodafone, anything you take, okay, whether in US or India, anywhere you take, you will have lot of options. Sometimes you get mad at looking at those options, which one to select. They'll have 100 options, right from 5 rupees, 2 rupees, 1 rupee to 1,000 rupees, 3,000 rupees, 4,000, 5,000 rupees. Why do they have so many options? They do not want to lose their customer to some other competitor. They want to have All options. Somebody who wants internet for only one day, you give them internet for only one day. It's 7 rupees, one day, unlimited internet. If they want somebody for 1 year, let them give them option for 1 year, right? You are creating plans for everybody because for you, everybody is important. Every single customer is important. Now, if you figure out that you can reduce your bill by moving to a different company. Let's say you're using Airtel, and you realize that you can you can save money by moving to Vodafone. That's what happened when Jio came, right? Jio gave unlimited calls, 300 rupees, unlimited calls. Everybody moved to Jio. Why? Because they were spending more on both Airtel and Vodafone, right? They were spending more than 300 rupees per month. So for them, it was like a very good deal, right? If you're spending 350, 400, then you should move to Geo because they're. So what is happening is in retail, sorry, in telephone company, retention of customer is more important than your bill. Okay, if you pay 100 rupees more, for them it's not doesn't matter. But you as a consumer is important because you'll be spending 100 rupees every month. That's when they make money. You spend 100 rupees more once in a week, okay, once in a year is not helpful for them. They want you to spend every month, right? So for service providers, it is number of customers which is important, not the bill. So they help you to reduce your bill. Okay, they will work with you to reduce your bill because if you are not reducing the bill, I remember not long time back. Anyway, anyway, I don't have postpaid Airtel now. Earlier I was having postpaid Airtel. I'm telling you 10, 15 years old story. At the end of the telephone bill, I get a printout bill and then they'll tell you, okay, if you switch to this plan, your bill would have come to so and so. They would recommend you go move into this slab. Your bill is now 700 rupees. If you had moved to this slab, your bill would have come to 400 rupees. They want customers to reduce their spending. Because the moment I realize that I'm spending more with this provider, I will quickly switch. So in retail, your first category, small customers are your target. But in telephone provider, these larger customers are the target. How can I move them to middle? Did you understand? So that's why domain knowledge is important. Okay. Domain knowledge is critical for doing this kind of analysis. And you will learn as you do more and more work, you will learn. So here clearly it makes more sense to move these large spending customers to spend less because they are easy target for your customers, to your competitors, sorry. Okay, they'll say, $50 unlimited calls. Everybody from 90 to 120 will move and go to your competitor. You will lose 30% of your business. One single day, 30% customer gone. Correct? You don't want to do that. Okay. So that's where now you will recommend to your team as a marketing manager. 30% customers are at risk. We have to give them a better option. We have to call them probably or come up with a new plan where we give them better option to reduce their monthly expenditure. You reduce, look at this data, analyze the data, and come up with a new plan where these all 90 to 120 people will be able to reduce their consumption or the charges bill by 20%. Right? And customer will like your service. Customer will think that you are doing a great service to them, right? If let's say you have a customer, you call them and saying that if you do this, your charges will come down by 20%, they're going to like your service, isn't it? So it works both ways. Here, more important thing is the customer. Okay, of course, spending is important, but not at a risk of losing them. Okay, so your headache will be this 30%. How can we give them better discount, better option, come up with new plan so that their expenditure can come down. Did you understand? So this is how you attack a problem, okay, and then come up with recommendation. Make sense? So
Yes.
yeah, we have just seen, okay, our first graph or first graph. We'll learn to build also, okay. Going forward, we'll learn to build this also. But this is the usage of histogram. Okay, and you can make and this is simple. Okay, we didn't have to create any complex graph or simple. We just created this and then made the simple graph, and you are able to make a important decision just based on histogram. Okay, and of course later we'll see how to build it. Now let's move to something which is important here. Okay, I'm on my pie charm. Okay, we'll talk about basic statistics. Okay, what is statistics? How does it help? Okay, why is it important to perform your data analysis? Okay, so first of all, if you look at the statistics, there are two parts to statistics. Okay, we call it as descriptive statistics, and then you have inferential statistics. What we just did in histogram is called descriptive. What happened? Okay, how was the usage? Okay, when you're trying to look back and understand what exactly happened, why it happened that way, okay, that's called descriptive statistics. You're describing what happened. Think in this way. You're describing what happened. Okay, and when you describe what happened, you will take entire data and describe. All the data is given to you. You have access to all the data, and based on all the data, you are coming up with those histogram. Okay, so I'm not taking, okay, out of 200, let's take only 50 and draw the histogram. No, I took all 200. If we had 10,000 record, we could have taken 10,000 and drawn the histogram, right? No big deal. Okay, we could have drawn histogram with 10,000. We had 200, so we used 200. Okay, so here all data is taken into account. And we can draw plots like histogram, bar graph, etc. to understand what exactly happened. This is about what happened. Analyze what happened. Who was my top customer? Okay, who are my risky client? Okay, which is giving me more business? Which business is giving me more profitability? Okay, so now you can decide a timeline. You can say, okay, last month, which business gave me more profitability last month, or which business gave me highest profitability last year. That's called descriptive statistics. Second type of statistics is called inferential statistics. Inferential statistics is you do not have access to all the data. You have access to some data. Based on some data, you are making your inferences. You are making your analysis. Okay, it is more about futuristic. Okay, now when you have election results, right, or election, so these companies, right, the statistics companies, they perform exit poll or post poll and pre poll, right? What do? They go and interview people. Now, even if you look at the state election, there will be crores of people living in a state, right? But they will interview only 2,000, 2,500, 5,000, 10,000. They will not even interview 1 lakh. And we have 10 crore, 5 crore, 7 crore population of, I'm talking about general average state. Otherwise, you have bigger state will have many crores, right? 50, 60 crores. I'm sure UP will have definitely at least 40 crore. Okay. Or Telangana itself might have maybe 12, 15 crores, 20 crores. I don't know. 15 crores at least. But we are talking to only 1,000 people, right? We're talking to only 20,000, 10,000 at max, 20,000 at max. Based on the response those 20,000 has given, we are predicting for all the seats for all the for all the people, isn't it? So there is a science behind it. Okay, it's not just randomly talking to everybody and then coming up with this. There's a science behind it. That science is part of your inferential statistics. Okay, so generally, if you talk about data analytics, okay, we'd focus on descriptive statistics. This is your data analytics. Okay, if you get into the actual difference between analytics, this is the data analysis. What happened? Okay, this is your, and we have a lot of graph here also. This is generally we learn, we perform machine learning algorithms. This is your data science. You are applying science on the data, okay, because you don't have access to all the data, you have to apply some science on it. Okay, and data analytics is you have all the data, you're analyzing what happened in the past. Here inferential is about future generally, okay, in terms of our work we am talking about. Okay, so so that data science, okay, and inferential statistics we'll do later. First we'll focus on descriptive statistics, okay, where what happened last month, last year, last quarter, last week. Okay, who is my best customer, who is my worst customer, who is my most profitable business, etc. Then we'll talk about what is called as types of data. Okay, we spoke about types of data in Python, right? We spoke about int, float, etc. But what is how many types of data are there from the statistics perspective? From statistics perspective, we have something called as numeric data. Then you have something called as categorical data. Okay, all these are there in the same app that I told you, Story Mantra app, UCAV, and I'll also share the information here. So when you say numerical data, these are your numbers. Okay, and it can be any number. Okay, if I ask you what is the price of a biscuit packet, right? It could be 1 rupee, 10 rupees, 5 rupees, 100 rupees, 150 rupees. Some of the expensive biscuit packets are expensive, right? It could be 150 rupees, right? It could be any number. That's what we call it as numeric data. Okay. And then second type of data is called as categorical data. Here, it cannot be any number. You have a group and the output is from that group only. Okay. When you're predicting, you can only predict from that given group. Okay. So, which state you belong? Right? If I ask you which state you belong, we have limited number of states. Now, when I say limited number, it could be, 30 or it could be 60. In case of US, 54. I don't know how many, 55, or it could be 29, 30 in our case. So even though you have 30 numbers, but your answer can be one of those 30 only. Okay, you cannot say something beyond that 30. Which region you belong, right? Are you what gender you are? Right, so you have male female, two genders only. So the value that you're going to talk about is within that given range, not range also, sorry, given values. Range means 0 to 10, like, no, not like that. So here you're talking about categorical data where values are given and your output is one of these. So in data science we talk about whether the customer will buy your product or not. Customer will buy your product or not, yes or no. So which data are we using? We are using categorical data. Okay, what will be the price of house next year? Okay, to data science, but that's a numeric data. Okay, how much was the sales made last year? Numeric data, right? Okay, which business division made more sales? Now, which business division, you might have 100 business divisions, but also that's a limited number, right? You might have 20 business divisions, 30 business divisions, or whatever, right? So still you have limited number only. You can't have anything beyond those 100 or 30. I mean, like GE and these big companies will have many divisions, but that's fine. Okay, you have limited divisions only. Okay, 100 is also limited in the sense which division has maximum profit will be one of those given divisions. Correct? So that's what we call as categorical data. Then in categorical data also, after categorical data, you have something called time series data. Time series data is similar to numeric data, but it has time component to it. Okay, it is very similar to your numeric data. Okay, but it has time component. If I ask you, what was the sales? You'll ask me, is that talking about daily sale, quarterly sale, weekly sale, monthly sale, annual sale, isn't it? So sale is a numeric data, but you have component to it like weekly sales. It becomes time series data. There's a time component also. It's time sensitive data. Your weekly sale definitely will be lower than your monthly sale, will be lower than your annual sales, right? So that's the the time component to it. Okay, so that we call it as time series data. But most of the analysis, okay, we are doing will be based on numeric and categorical, right? We'll do a little bit of time series and we'll do a little bit of text data, right? Text data is like, you are analyzing tweets, right? Now if you're just taking hashtag also, okay, if you're just comparing equal to, probably that is like categorical data, right? But if you're trying to understand whether that tweet is positive or negative tweet or neutral tweet, we call it as sensitivity analysis, sentiment analysis. Okay, sentiment analysis is one example. Sentiment analysis means you're trying to understand whether that content that is coming, let's say you are analyzing news for your stock, you have identified 10 stocks and you want to understand every news. You can't read every news, right? So I've created some kind of algorithm which will take the news from Google News and tell you positive or negative news. Of course, positive news will help your stock go up, negative news will pull your stock down, right? You want to understand each news that is being coming on Google News, is it positive or negative? Okay, so there are ways to do that. Okay, so that is called, you're analyzing text. There's no new number there. Okay, let's say not good. Okay, when you hear good, result is good, Wipro gave good result. When you say good result will mean, oh, it's a positive news. Wipro did not give good result, did not give good result, did not good, that means positive but negative of positive. Did not is negative, right? Not not good. So not good is negative of good is bad. That becomes a bad, bad news. Okay, you're just trying to understand positive or negative. Then it might say Wipro did not give bad result. Not negative of negative is positive, right? So it means positive news. So there are some relationship, okay, that we'll see later how to handle it. But here you're talking about sentiment. You're analyzing text data. It's a text data, tweet data, Facebook post, right? Okay, when somebody makes a comment on you, your product is not good, right? When somebody writes a review in Amazon, let's say you're a seller, right? You sell books. Somebody writes a negative review about your book. That's the negative review. You want to hear why the negative is, review is negative. So you're talking about text data there. You're analyzing text data. Okay, so these are different types of data. Let me open my notes. Okay, just give me a second. With that, we will end. Just 2 minutes, okay? Sorry. Okay, so we'll talk about this tomorrow, okay? I don't know, did I pull out the right file? This is not the first thing I want to talk about here. I want to talk about these things tomorrow, okay? Just ignore.
Sir, based upon the data, graph will be selected, no, sir?
Yes, because see, you can't draw a bar graph for a text analysis, right?
Yeah.
But for that, you have to select some different graph,
Yes, sir.
right? So we will also talk about which graph for better, what kind of analysis that graph gives. Okay, it should be here. Why? Wait. Okay, I think we will do it tomorrow only. Wait. This should have been here. Yeah, it is here. Okay. I think I opened chapter 2. I should have opened chapter 1. Okay. So this is what I was talking about. Data set, right? Numerical. Okay. It's called numerical or quantitative data. Okay. You can also call it quantitative data, like height, cost price, total cost. Okay. Number of male students, number of female students in a class, right? These are all your numerical data. They are called discrete data also, countable. So your numerical can have discrete and continuous. Okay. So what is meaning of discrete and continuous? Discrete means, okay, now if I tell you marks obtained in a class, right? If you look at the marks obtained, it can be 1, can be 0, 1, 2, 5, okay, 100, 75, 79. It can be 75.5. It cannot be 75.9999, correct? So when you talk about continuous data, it means any data is positive. Sorry, any data is possible. Any data is possible. Average, for example, if you calculate average can be anything, right? 23.33333 also is possible, correct? But marks as such, it's discrete. Okay, so discrete is like numeric data. Okay, similar to numeric and categorical, right? I mean to say, it's not, see, categorical means you will have either this or that, either 74 or 75 or 76. Here it can be 75.5 also. Okay, but it cannot be any data. Okay, so when you generally plot discrete graph, okay, your discrete graph will be bars. Okay, like 5, then you'll have 6, then you'll have 7, right? You will not have anything between 5 and 6, or 6 and 7. Between 6 and 7 you will not have, or between 6 and 6.5 you will not have. That's called discrete data. Continuous data is where anything is possible. Anything is possible. 5.99999 is also possible. 5.6666 is also possible. So generally, when you talk about continuous data, we represent as a continuous line. Okay. So if I can show you one example here. So if I have to draw a discrete data, I will show you something like this. Okay. So here you have 5, or maybe not even like that. Okay. So let's say 5, then 7, then 8, then, something like this. So, that means after this, directly it became this. After this, directly it became this. Between this point and this point, it is not possible. This point and this point, it's not possible to get this value. Let's say if this is 5, and this is 6, and this is 7, it's not possible to get anything between 6 and 7. So generally, discrete data will be like steps here. Okay. Continuous data will be like your line, like this. This means if this is your 5 and this is your, say, 6, here also these values are possible. Anything is possible. So this is called continuous data. Continuous data is of two types again: interval data and ratio data. Can you guess what is the difference between interval and ratio? Your interval data, okay, so if I say I got 50% and you say you got 100%, that means you have got twice marks than me. Okay, so okay, let's talk about continuous. Let's skip it. Interval data, right? So this is like interval data. Okay, interval data is where you have some block, like temperature, right? Temperature, you can have 70 degree, 71 degree or 71.5 degree, 71 degree, 72 degree, 72.5 degree. You cannot have 72.25 degree, right? So here there is an interval, and not every value within interval is possible. Okay, it is continuous because it can have any degree, right? But there is an interval scale. I just said, right? If you say I got 40% marks, you got 80% marks, that means you got twice the marks compared to me. Okay, that is called interval data. Interval. Okay, so when you draw a line, okay, if you draw a line, if this is 0 and if this is 100, okay, so if I get 30 here, 0 to 30, it will be same distance 30 to 60 also, isn't it? Okay, so it's called equal interval, right? 30 degree, 30, 30, 30, 30. It is equal interval. Ratio is when you are dividing into multiple parts, okay? So ratio is, okay, now if you look at this is age, and in that age, which digital product that they own. So they say 38% of people in age group 24-25 owns laptop. Okay, 29% of people within this age group uses phone. So here there is no twice or thrice, right? We are just trying to measure what is the contribution to that group, right? Total is 100%. What is the contribution that is being made? That's called ratio. You are dividing the actual value by total, right? By 100. So here we are not bothered about the ratio. Of course, we can say, like 12 and 30. They own 3 times more. People own laptop than digital camera, right? Something like that you can say. But here, main intention is to show the contribution. And in the ratio, you are showing the contribution. And in interval, it is about how much more, right? And both of these are part of your numerical. Okay. Then if you go to, we'll talk about visualization tomorrow. Okay. So ignore this. Then you have categorical data, right? So I told you categorical. Categorical can be of nominal and ordinal. What is nominal? What is ordinal? Nominal is where it's just for category. Okay. We spoke about groups, right? Categories, right? We spoke about categories. If categories does not mean any significance in the order you name, for example, male, female, right? Whether you write male first or female first doesn't matter. Okay, the group is there only for nominal. It's going to tell you how much contribution is by female, how much contribution is by male. But if you talk about, good, average, bad rating, right? Good, average, bad. There's an order you can write. You cannot write average first, good next, and bad last. Either you write good, average, bad, or bad, average, good. Right? Generally, we write bad, average, good, right? Lower, then higher, then higher. So where order is important is ordinal. Where order is not important is nominal. Order is not important. Male, female, correct? Region, north, south, east, west. Which state do you belong? State A, B, C, D. Order doesn't matter. Okay, you put in alphabetical order, you can put it in alphabetical order, but it's just for namesake, right? It does not mean that if you put something first, it is less privileged. If you put last, it is more privileged. No, right? It's all the same. Ordinal is where order matters, right? So if you talk about nominal data, you have male, female, north, south, east, west. Okay, cars, Maruti, Tata, Mahindra, Toyota, Ford. These are just the name, right? Groups. Ordinal is where order matters, like for poor, fair, good, very good, excellent. Okay, order matters. I cannot put very good first, poor next, good then, fair. No, it has to be in same order. Grade, E, D, C, B, A, or A, B, C, D. Generally, we write from lower to higher, isn't it? Or preference, first choice, second choice, third choice. Because order is important. Good is more than, excellent is more than good. Good is more than poor. Okay, A is more than B, B is more than C. Order is, here you cannot say by how much. If you can say by how much, so this is the difference between interval data and your categorical data or ordinal. A is more than B, but how much more? No, we cannot say by AB, right? When you can say to perfection, oh, twice more than B is A, that becomes your interval data. Numerical interval is that how much number, how many, how much. Okay, here it is just the group categories that you write. There's no, so you cannot say that A is twice as important as B, B is thrice as important as D. No, okay, because see, even if you convert average to grade, if you say 70 to 80 is grade B, 70 will also get grade B, 80 will also grade B. So now between 69 and 70, there's 1% marks and one grade change. 69, 80, 10% difference, and then grade change. So you cannot say to perfection that it is twice or it is thrice. That's why it's called categorical. When you can say how many times it is more, it is your interval. Okay, so we'll stop here with our data types. Any questions before we end?